Over the last 10 years, fluctuations in commodity prices and unpredictable rainfall patterns have increased the importance of managing the agronomic and economic factors influencing row crop production in South Carolina. Through supplemental irrigation, stabilization of yield from year to year can be achieved, reducing risk and assisting with enterprise budgeting and economic decision making. Due to recent changes in groundwater regulation and monitoring for agricultural use in South Carolina, utilizing efficient irrigation methods that provide economic benefit to growers are needed to promote sustainable row crop production in the future. With approximately 18% of South Carolina row crop acres needing irrigation, almost all of which use overhead center pivot irrigation, the need for research on alternative irrigation methods such as subsurface drip irrigation is needed to determine whether these efficient irrigation methods are feasible and suitable for use in the future. A research project was initiated in 2019 to determine the optimum depth and lateral spacing of subsurface drip tape for soybean production in South Carolina. This project was sponsored by Toro Ag, a leading provider worldwide of innovative solutions for irrigation. One irrigated field that represents the South Carolina Midlands region was used in this study at the Sand Hill Research and Education Center near Columbia, South Carolina. This site was selected due to ongoing issues with drought stress on row crops as a function of soil texture and the existing infrastructure at the wreck. Soybean was planted on 30-inch row spacing in late May in both 2019 and 2020 and has been managed throughout the growing season in accordance with Clemson extension recommendations. Subsurface drip tape was installed at three different depths, 5, 10, and 15 inches, and at three different lateral spacings, 30-inch spacing under the planted row, 30-inch spacing in the row middles, and 60-inch spacing under every other row middle. Each treatment was replicated 4 times across the field. All drip tape was installed with RTK guidance to ensure the location of the tape would be known for future years. Irrigation was applied in equal amounts to each treatment throughout the season. Upon harvest, water use efficiency can be calculated, thus indicating which treatment provided the greatest yield per volume of water applied. Recommendations of lateral spacing and depth of drip tape for similar soil textures would be made accordingly to maximize water use. From this research, we expect to determine the optimum lateral spacing and depth of drip tape in a row crop setting for sandy soil textures in South Carolina. This research fits into the Sand Hill Research and Education Center mission by using science-based research on precision irrigation application practices to increase irrigated soybean profitability. This research is important to South Carolina soybean growers because it will provide information and replicated data to assist them with infrastructure investment, planning, and maximizing soybean yield in the future.